Dear students, today we're going to learn about the derivatives of the rest of the trigonometric functions. But let's start with the review. Last lecture we learned that derivative of sine is cosine. So today let's start with an example. Find the derivative of the following function. Sine cubed of x cubed plus 5x squared minus 17. As we know, this cube over here is just an abuse of notation. So theoretically speaking, it should have been written as sine of x cubed plus 5x squared minus 17 expression cubed, and we would like to find derivative of it. So as I explained in class, when we want to find the outside function, we have to try to plug in x. If we would have plugged in x, we would calculate x cubed, then 5x squared, then we would subtract 17, and we would calculate sine, and the last thing we would do is we would cube it. Conclusion, our cube is the outside function, and sine of x cubed plus 5x squared minus 17 is the inside function. According to the chain rule, we have to use the power rule first. So 3 goes down, then we have sine of x cubed plus 5x squared minus 17 quantity squared, and then chain rule says multiply by the derivative of the inside function, which is sine of x cubed plus 5x squared minus 17 derivative. So we're looking for the primes. There is no prime over here, so this part is done. And we just have to find derivative of this function over here. But unfortunately, we have to use the chain rule one more time. So what would be the inner function? What would be the outer function? If we would plug in x, we would calculate x cubed, we would add 5x squared, we would subtract 17. And then we would take sine of it. Therefore, sine is our outside function, and x cubed plus 5x squared minus 17 is the inside function. So let's try to apply chain rule second time. We rewrite the first part of the expression since it's already done. And I will take and write exponent 2 on top of the sine. Then we're going to use the chain rule for the second part. Derivative of sine is cosine, so we have cosine of x cubed plus 5x squared minus 17 multiplied by the derivative of the inside function, which is x cubed plus 5x squared minus 17 derivative. No prime, so we just need to find derivative of this function. So we have 3 sine squared of x cubed plus 5x squared minus 17 times cosine of x cubed plus 5x squared minus 17. And now we calculate the derivative of x cubed, which is 3x squared plus 5 times the derivative of x squared, which is 2x. And derivative of 17 is 0. And as we agreed before, we don't really need to simplify. So that's our expression for the answer. So we reviewed a little bit the derivative of sine. Let's do one more example before we move on. In this example, we have to find the derivative of x divided by sine of x. Here we have a fraction, so we're going to use the quotient rule. Quotient rule says find derivative of x, multiply by the sine, subtract x multiplied by the derivative of the sine. On the bottom we have sine of x quantity squared. Now we find derivative of x, which is 1 times derivative, I say derivative, it's not correct, times sine minus x times the derivative of sine, which is cosine. And on the bottom we have sine squared of x. So finally our answer is sine of x minus x times cosine of x divided by sine squared of x. So after this short review, we will start with the derivative of cosine. So we would like to find the derivative of cosine. We have to find derivative of cosine by using the definition. So limit when delta x goes to 0, cosine of x plus delta x minus cosine of x divided by delta x. And we need to simplify this expression similarly to the sine by using the formula for the cosine of the sum. So the formula for the cosine of alpha plus beta is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And then we're going to apply this formula to this expression. So we're going to get limit when delta x goes to 0. We have cosine of x times cosine of delta x minus sine of x times sine of delta x minus cosine of x divided by delta x. Then we would like to group this cosine over here with this product, which also has cosine. And we're going to write it as two different limits because we have a minus over here. So let's do that. We have limit delta x goes to 0. The first fraction has delta x in the denominator, has cosine of x, cosine of delta x in the numerator, together with this cosine at the end of the previous fraction. Then we have a minus, then we have a limit, delta x still goes to 0, the denominator is delta x, and we have to take this part and write it over here. Sine of x, sine of delta x. So we're done with this step. Let's look what we need to do next. We have cosine, which is a common factor, and it doesn't depend on delta x. So we can take it and put it outside of the limit. So we have cosine times the limit when delta x approaches 0. We're left with cosine of delta x minus 1 divided by delta x. Then in the second expression, this sign doesn't have delta x inside, so we can take it and put it outside. So we'll have sine of x times the limit delta x goes to 0. We're left with sine of delta x divided by delta x. So this is our famous limit. We know this limit is equal to 0. So the first part of the expression will be 0. I forgot to write my minus. Alright, so we know this famous limit is just 1. Finally, we have our answer. Negative sine of x times 1. So, conclusion, derivative of cosine is negative sine. Derivative of cosine is negative sine. That's one of the famous limits that famous derivatives that we're gonna use. So while we're doing the derivatives of trig functions, let's do derivative of tangent. So we would like to find derivative of tangent of x. And we know that tangent of x can be written as sine of x divided by cosine of x. So we're going to use the rule for the quotient. Quotient rule says take the derivative of the numerator, multiply by the denominator, subtract numerator times the derivative of the denominator. As you can see, I'm using the d notation just to slowly introduce it. So what is the last step over here? We have cosine of x quantity squared. Now we're going to calculate all these little derivatives that we have. Derivative of sine is cosine, so we have cosine of x times cosine of x. We have minus, we have sine of x, and we just calculated derivative of cosine. We know it's negative sine. It's important to put a set of parentheses. So we have cosine squared of x on the bottom. Let's calculate it, the numerator. We have cosine squared of x minus sine, and minus sine gives us plus sine squared of x divided by cosine squared of x. And we know from the identities from 2 classes ago that cosine squared plus sine squared is equal to 1. So we have 1 divided by cosine squared of x. But we also know that 1 over cosine is exactly secant, so this is secant squared of x. Conclusion. If we want to find derivative of tangent, it's gonna be secant squared of x. Alright, the next one that we need to calculate is derivative of secant. So secant of x derivative. And over here again, we're not going to go to the definition, we just try to use the identity. We know that secant is 1 over cosine. And so we're going to apply quotient rule one more time. So it's going to be derivative of the numerator, so it's derivative of 1 times cosine minus 1 times the derivative of cosine. And again, I'm using the d notation just to slowly introduce it. On the bottom, we have cosine of x squared. We know that derivative of 1 is equal to 0. So the first part of the numerator will be 0. And the second part of the numerator will be negative 1 times negative sine of x. On the bottom, we get cosine squared of x. So minus 1 and minus sine will give us sine of x divided by cosine squared of x. And this would be fine, but we can simplify it a little bit, and we can write it as sine of x divided by cosine of x times 1 over cosine of x if we take cosine squared and split it as cosine times cosine. But you can clearly see that the first expression is tangent, and the second expression is secant. So we arrived into our answer, which gives us the conclusion. Derivative of secant is tangent times secant. Two formulas I will give without derivation, but you can try to go through them on your own. One formula is for the derivative of cotangent. Derivative of cotangent is negative cotangent of x times cosecant of x. And derivative of cosecant of x is negative made a mistake. Let me start over. Derivative of cotangent, I didn't say it right, it's negative cosecant squared. So one more try. Derivative of cotangent is negative cosecant squared of x, and derivative of cosecant of x is negative cotangent of x times cosecant. Sorry about it, but everyone can make mistakes even on the video. Alright, so before we move on, let's do one example for these trigonometric functions, and then you will have to practice with the homework. Find the derivative of f of x, which is secant of x divided by 1 plus tangent of x. So we have to apply quotient rule over here, and the quotient rule says find derivative of the numerator, multiply by the denominator, subtract the numerator times the derivative of the denominator. As you can see, I'm writing everything out, because when you're just learning, suggestion is not to skip steps. And on the bottom we have 1 plus tangent of x quantity squared. Alright, so let's try to do this out. Derivative of secant. We know that derivative of secant is secant times tangent. So we have secant of x times tangent of x times 1 plus tangent of x minus secant of x times the derivative of 1 plus tangent. And derivative of 1 is 0, and derivative of tangent is secant squared. So we have secant squared of x. In the denominator we have 1 plus tangent squared of x. So for all purposes we can stop over here, or if we want to simplify it a little bit, we can try to factor secant out. So if we take secant and factor it out, we will be left with the following expression. We'll take tangent, we will distribute it through the expression, so it's going to be tangent of x plus tangent squared of x, and out of the second expression, secant of x we factored out, so it's going to be negative secant squared of x, divided by 1 plus tangent squared of x squared. Alright, and we know that tangent squared of x minus secant squared of x is equal to 1 from the identities. So this is just negative 1. This is negative 1. Alright, so finally we have secant of x times tangent of x minus 1 divided by 1 plus tangent squared of x squared. Made a small mistake. This should be just tangent, should be just tangent. Sorry about it. Should be just tangent. Alright. I think this is fine for the derivative of this function. I think we're gonna stop here for this lecture. Alright, we'll see you in the next lecture.